Hello guys, Vivek here, and I'm getting a lot of question upon this topic, that what is the difference between generator and alternator. But where is the difference? Aren't they same? Many people say that both of these things are similar and they both do the same thing. So generator and alternator is the same thing. Well, this is not incorrect at all, because both of these machines are used to convert the mechanical energy into electrical energy, and both take the same thing, same amount, same power, that is the mechanical power, and their primary work is to generate electricity. But where is the difference? The difference is in their construction. There are certain differences, and in this video I'm going to discuss about the same. So here you can see that I have just completed up a chart. Okay, so here I have written generator and here alternator. In the both of these sections I'm going to differentiate between them. The first difference basically for a generator is that by generator we mean a machine which generates DC current. Okay, you have heard about DC generator. Okay, so DC generator, it can also be an AC generator, which we called induction generator. Okay, or AC generator, which is basically an induction motor which is working at certain conditions where it generates electricity, while an alternator is only meant for generating AC current. There is no DC. Okay, you can understand it by the fact that it is called alternator. You can see that it's called alternator. So alt means the alternating current. Okay, so alternator means alternating generator. It can be defined in like that manner. Okay, now let me rub this up so that I can continue with the later points. Okay, so generator and alternator. The next thing that is really important, apart from which machine generates AC and which machine generates DC, it is important to look at the construction. By general construction, a generator has something like this kind of figure. There are two magnetic poles which can be permanent, or which can be electrically connected electromagnets, or it can be permanent magnets. So you can say that this is north pole and this is south pole, and the field is stationary. Okay, the magnetic field which is there is stationary, while there is a shaft which rotates and generates electricity. Okay, it's something like that. I'm sorry for my bad drawing up here. Okay, so this shaft is actually rotating in certain direction. Okay, so the conductor, it carries up a conductor, and what we get, the electricity we get from this terminal. From here we get the electricity through brush and slip ring and all those things. Okay, sorry, commutators, not slip rings actually. So we get electricity from here. Okay, plus minus. Okay, so the magnetic field is stationary. Magnetic field is really stationary. Okay, the magnetic field is stationary. It is a standby one, whereas the armature, or the there is a rotating part, or the conductor is what rotating, while in case of alternator the thing is different. An alternator basically looks like something like this. This is a kind of rotor, you can say, of an alternator. Okay, it looks like this one. This is the general drawing given. Okay, it carries up a winding. This is called the field winding. Okay, the field winding looks like this one, and it is connected outside with an battery source or with an exciter. Okay, and it rotates within a frame, within the stator frame, and this is rotating. Okay, and this is connected of course through brushes. Okay, so the exciter is there, and it has certain polarity, north pole, south pole polarities of course there of the rotor, and here on the stator remains the stator conductors. Here you can three-phase conductors are there. Okay, so when this magnetic field is cut by this conductors, the electricity is generated in three phase. Okay, it is like this one. So there is the difference between both of these machines. While in case of a generator, you can see that the field is stationary, the field is not moving, while the conductor which is there for generating the electricity, which is responsible for output, is rotating. While in case of the alternator, the field is rotating, while the output wires are not rotating, or the output conductor is not rotating. It is stationary, fixed to the stator. There are certain advantages of this design. About alternator, people do ask me why we not connect the stator, why we do not make it like generator, like the field is standby, and these three-phase conductors are moving one. So you can make this one, but this design is really economical, because you see, if this is rotating, if the three phases are rotating, okay, the three-phase conductors are rotating on the rotor, so you need to give three slip ring and brush arrangements, right? Okay. Whereas in case of excitation, where in case of rotor, you only have to give two of these. Okay, so only by connecting two brush and slip ring arrangement you can do this thing. Other than this, there are certain economical advantages, like on the design basis, to make this rotate is to make the three-phase conductors rotate is not that economical. In case of you need high power, okay, in case of high power demand, it is always recommended that the field is rotating one, while the armature conductor, so you can say the output conductor, is stationary one. Okay. Another difference is not that important, but this one was really important difference. You should note it down, that what is the basic difference between this generator and alternator. Okay. Apart from that, what other points coming in my mind is that a generator is bigger in size compared to an alternator. Okay. A generator is bigger in size. Okay. The first thing, it is bigger in size, big enough. Okay. And another thing that is really important, that it has a really low weight, sorry, it has high weight per kilowatt output. Okay, that means the weight of a machine for 1 kilowatt output is really greater than that of an alternator for similar purpose. Okay. In context to this. Okay, so alternator is basically used for, that's why this is recommended for high power output, whereas generator is not that much used. Okay, if DC is required, nowadays rectifier units are connected to alternator. Okay, it is connected to rectifier bridge, which can economically convert the AC current to DC current. Okay, so these are the basic differences between generator and alternator. One of the only exception you can say is the induction generator, which is not that much used. It is used in case of windmills. You can check it out on the Google. Okay, so it is the only you can say the exception. Other than this, an alternator is only used in case of production of AC, while generator can actually produce DC or AC both, but we mean by generator that a machine which generates DC current basically. Okay, so this is the basic differences. Okay, so moving to the next slide. Okay, so basically you make it note that a generator means the field remains stationary while the conductor is rotating. The conductor is the armature, okay, the armature from which we are getting the output, while in case of an alternator, the conductor is stationary while the field is rotating one. Okay, so this is the basic difference between generator and alternator. I hope you have liked my video. If you have liked this video, please share and subscribe to my channel. I will bring more such videos, and if you do subscribe me, that encourages me to bring more such informative videos. Okay, so do subscribe me over here on YouTube. And you know, I have started my blog, The Electrical Engineer. In last videos I have discussed about them, so please do visit there and subscribe to my blog and also to my YouTube channel. Okay, so that I can bring more such informative videos for you. So with that said, thank you very much.